In this video, I want to show everybody how to utilize some technology to check your solutions for these first and second order differential equations as well as initial value problems. So what you can do is you can use this website Wolfram Alpha. I'm assuming a lot of you have heard of it, but if not, you just go through, type in Wolfram Alpha into your URL search bar and just bring it up. And the way it works is you can pretty much enter anything into this field and it will go through and it will solve it for you as long as there's some sort of solution. So let's say, for example, you wanted to solve a really basic differential first order. Let's say y prime plus 1 over x y, 1 over x times y. And the syntax is pretty forgiving. It's going to be equal to e to the x. And a lot of times in computer programming, for those of you that never programmed anything, use exp for e to the x. And we're going to solve it. And I'm going to hit enter. Okay. And then what it does is it gives you the solution. Okay, so you can see right here, it tells you it's a first order linear, and then it does some factorization. So it's pretty cool that it can solve it really quickly. For you to do this one by hand, you could either make it a linear type. I don't think you could make it separable too easily. So that's pretty cool that you can do that. You can also do an initial condition. So we can say y at 0 is equal to 1 if you wanted to do some initial condition type of problem. And what it'll do is, remember all this C1 that's right here, that should go to a constant when we solve it. All right, so let's just go ahead and solve. Actually, let me change that because I think 0 is not in the domain, so we can't be guaranteed a problem. So let's try y at 1 is equal to 1. So sorry about that. Right. And right here gives you the solution, and this is going to be your particular solution. So it's pretty cool that we can use technology, the Wolfram Alpha, without really knowing a programming language, such as MATLAB or Mathematica, to be able to solve our differentials. It works really nicely for second order differentials. All right. Oh, and by the way, it does show you the graphs of the solutions as well, so that's pretty cool. Now, it will probably ask you to do the step-by-step. Not surprisingly, guess what you're going to have to do? You're going to have to pay. All right, so if it helps you, I can't remember how much it is, but it's probably a monthly fee. So I would just suggest not paying. All right. What about a second order? All right, so how about this one? Y double prime plus 2y prime plus 10y equals 0. All right, so just a second order homogeneous. Right. Now remember, we had to make a characteristic equation, and then we had to factor it, or if it was not factorable, we had to use a quadratic formula, blah, blah, blah. All right. Notice right away, it solves it. It actually classifies it as a type 3, the one where you have the complex solutions. And notice you get your cos 3x, sine 3x. It distributes that e to the minus x, all right, because I think the solution is x is negative 1 plus minus 3i. And it just goes through and solves it really nicely for you. If you want an initial condition, you could say comma, y at 0 is equal to 1. And you could say y prime at 0 is going to be equal to 2. And that'll solve it really quickly for C1 and C2. So right away, it gives them both as 1 for C1 and C2. I'm going to change that just to make sure. So let's change this to 4 or something like that, because it's really weird that we got 1. All right, there it is. So that's pretty cool. You can solve it right away. Even cooler is if it was a non-homogeneous. Right? So if it's non-homogeneous, then you have to use one of those horrible methods, undetermined coefficients, or even variation of parameters, which we choose not to do if we can't. All right? So let's say for some reason this is going to be equal to t plus e to the minus 2t. All right. And we could certainly use our variation of parameters on this, all right, if we chose to. All right. And let me change this. I'm going to change the coefficients to 3 and 2. All right, and I'll show you why in a moment. All right, so let's execute it. It takes a little bit, but goes through, finds the solutions. Okay, pretty cool. I want you to notice that there's 3 E factors in here. And it's like, okay, well, why would you have 3 exponentials? Oh, okay. Remember, there's a repeated solution. All right, so if you were to get the characteristic, one of the solutions, m, would be equal to -2. And so remember, you have to multiply by another factor of x, or t in this case, since t is the independent variable. So it gives us our general solution, and then it gives us our particular solution for this. Okay, so pretty cool. If I was to change this, so check this out. This is actually pretty cool. Let's say we have 2y prime and just y. And let's just change this to exp of -t. We're going to get one of those type 2 cases. Okay, so we're going to actually have a repeated root with this, 2 repeated roots. So we'd actually have to have a t square in addition to our t and our coefficient in addition as part of the particular solution. So I'll go ahead and execute it just to show you. All right, so right here in our solution, notice that we have a C2, a C1, and then we have a T square. All right, because we have a T back here as part of the general solution. So pretty cool that we can do this. We can also get, not surprisingly, if we throw initial condition in there, let's say y at 0 is 1, and y prime at 0, let's make it something crazy like 6. So then here's our solution. It didn't give me as crazy of a solution as I thought. So just illustrating that you guys can use technology to be able to check your answers. All right, and maybe some of you use like Symbolab. For those of you that are programmers, you might use Mathematica or MATLAB or something like that. But I find Wolfram Alpha is really nice because it's free. It's very forgiving with respect to syntax, and it gives you pretty much everything that you need. All right, it gives you the graphs if you want them, and it classifies it. So pretty cool with this. So I would encourage you to check your solutions in the future using Wolfram Alpha.